Thank you for taking the time to join us today as we dive into Belden Universal's product offerings and custom engineered solutions. We'll be providing you with valuable insight into the construction and customization of universal joints and the various applications where they can be used. We'll start with a brief introduction of our company, then move on to a basic overview of universal joints, how they're constructed, their various components, and the power transmission role they fulfill in a mechanical system. We'll then cover the main types of standard universal joints and driveshafts in greater detail. We'll also review the various raw materials, coatings, lubricants, and protective boots available. At the end of our presentation, we will discuss a couple of case studies on customizing universal joints. Let's now dive into some background of who we are and why we're here today. Belden Universal is the world's leading manufacturer of custom universal joints and driveshafts made to our customers' exact requirements. We are AS9100 certified and employ cutting-edge, innovative manufacturing technologies which enable us to produce both small batches and full production runs of custom parts efficiently and cost-effectively. Belden Universal was established in 1997 with its headquarters in Hillside, Illinois, just outside of Chicago. We also have a European location in Berlin, Germany that represents our brand outside of North America. Starting with the basics, what is a universal joint and why should you use this type of coupling? Universal joints are a type of shaft coupling used to transmit torque and motion between shafts with misalignment. Ideally, input and output shafts should be perfectly aligned. In practice, displacement during operation, for example due to a technical restriction or vibration, are often unavoidable. These misalignments can be overcome with a well-selected universal joint or driveshaft. Universal joints can be found between motors and end effectors or gearboxes where other couplings are not an option or where the characteristics of couplings alone do not suffice due to angular or parallel misalignment or other demanding operating conditions. Let's examine the different power transmission conditions that would require a universal joint. If angular misalignment is greater than 5 degrees, a universal joint may be the only viable coupling option. This can be the case if the motor cannot be installed very precisely, or if the motor moves during operation or after installation. Sometimes the motor has to be placed at a higher angle to the outbound shaft due to other factors. Single joints can operate at up to 45 degrees, and double joints and telescoping driveshafts can operate at up to 90 degrees. Parallel misalignment often requires a double joint or a telescoping driveshaft. As an example, sometimes the motor cannot be added in line with the outgoing shaft because there is no room, so it is plugged underneath or above the direct line of the shaft. High torques and low or moderate speeds are often discouraged for most couplings. Couplings with the highest torque ratings, such as jaw or elastomer couplings, are also the least forgiving on angular misalignment. Conveying systems might require a relatively high torque at elevated angles, which demands the high torque and high angle capabilities of a universal joint. The same applies for manual remote operating systems of flaps or other types of valves. High temperature or highly corrosive environments can prevent the use of flexible couplings and require a universal joint. With special lubricants or dry lubricant coatings, universal joints can operate in higher temperatures than jaw or elastomer couplings. Ovens or other high temperature applications with moving parts like feeders or remote flap operators are another likely application. Universal joints can usually consist of two yokes, also known as forks, and a central cross-shaped element. When a cross is used, there are typically roller bearings or bushings required to install the cross. If the cross is built from a block and pins, there are ways to avoid bearings or bushings, but they can be added as well. A cross and roller bearing design is shown on the left. You can see a pin and block design on the right. There are also ways to add roller bearings and bushings to a pin and block design, as shown in the middle of your screen. The contact surfaces between the yokes and the central connector are what transmit the torque and motion, and therefore must carry considerable loads. The design and type of connection in these spots are critical for optimizing the performance of a universal joint. These spots are called bearings. There are two major types of bearings for a joint: plain bearings, also called friction bearings or bushings, and needle bearings, also called low friction bearings. Both plain bearing and needle bearing designs have their advantages. Plain bearings are usually simple, cost efficient, and can carry relatively high loads at low bearing speeds. However, they tend to be more difficult to lubricate, and heat generated by the friction can be a problem down the road due to wear or galling. Plain bearings can be adapted to the application by the materials used, such as alloys, stainless steel, and a combination of harder and softer materials like brass, bronze, or PTFE coatings. The needle bearing design generates less heat and therefore can operate at a higher RPM, but at a lower loads. They can also be sealed and permanently lubricated. Now, once you've identified the best bearing design needed for your application, there are many options to choose from for connecting the shafts to the yoke of the joint. The ends of the yoke that connect to the shaft are usually referred to as hubs. Some of the most common hub features are shown here, but there are many other variations and additions possible according to each application requirement. The next two slides show some of the specialized hubs we have created to meet customer needs over the last few years. The assemblies you see on the top left and top right offer female bores with a spline on the outside hub. The top left assembly features a male shaft on one end and has been turned down to a smaller diameter, while the other end is a flange connection. This assembly was used to steer an unmanned robotic transport vehicle. The assembly on the bottom left is a joint used in aircraft high-lift actuation systems. The assembly you see on the bottom right is used in the paper manufacturing machinery. The far left joint on this slide utilizes keyless bushings inside the female end. This joint was used in a vacuum application that manufactures computer chips. It also has a special protective boot that we designed and made from 316 stainless steel. The two central custom hubs feature split hubs. In a split hub design, the shaft are usually inserted into the split hub and a collar is added to the outside of the hub to be clamped down over the split hub, securing it in place on the shaft. The second joint is a small joint used in a medical application that requires the female hub to be split. The third joint is used in a bowling alley pin setter. To the far right is a joint used in a remotely operated vehicle for the offshore oil industry. It features a female bore on one end that attaches to the remote operated vehicle's tool, and then the square end is used to actuate the valve. You will notice the spring secured over the center area of the joint. This was designed to allow the assembly to remain straight or return to the zero position on its own so it can be easily inserted into the valve while underwater. Universal joints can be constructed as a single universal joints or in double universal joints. Different design subcategories include heavy-duty, high-strength, leveler, stainless steel, needle-bearing, and military standard or mil-spec. These base designs can be customized to meet the customer's specific coupling needs. Let's start with the different joint designs available for single universal joints. Single U-joints can compensate for angular misalignment of up to 45 degrees, depending on the size. They're available as needle-bearing or friction-bearing joints in any one of our friction-bearing design types: heavy-duty, high-strength, and leveler strength. All designs are available in our standard alloy steel, as well as a range of stainless and other materials. We will take a deeper look at the material options in another segment. There are a range of standard hub configurations that we offer, but we can also provide custom hub modifications. Now, let's look at each of the base designs. Our first joint design is a heavy-duty joint. Heavy-duty joints are high-quality joints used for a variety of standard applications with moderate loads and RPM. They're constructed with a block, a large pin, and a small pin that is secured in place with a snap ring. Smaller joints in this design have the pins pinned in place rather than using a snap ring. They are made from high-grade alloy steel and have hardened and ground blocks, pins, and yoke ears. The hardening increases the strength of the components, but even more importantly, improves the bearing properties of the components at their contact faces. turning these into formidable friction bearings. This design is easy to assemble and can be disassembled. High-strength universal joints are joints used for higher torque applications. They are also friction-bearing joints and are made from high-grade alloy steel. In this design, they feature a short pin, long pin construction and then are secured with a rivet. The short pin and long pin design has the advantage of having the same size diameter pins for both axes, thus making them stronger, since the large pin small pin design typically ends up with an oversized large pin and an undersized small pin. Blocks and pins, as well as the yoke ears, are also hardened and ground as on the heavy-duty series. Leveler-style joints are designed for extreme torque applications, often seen in steel leveling and metal processing equipment. Similar to the high-strength joint design, they feature a friction-bearing construction of the short pin and long pin secured with a rivet. Blocks and pins, as well as the yoke ears, are also hardened and ground. The leveler design offers a reinforced yoke profile, making it our strongest design available, although in some cases this reduces the angle of operation. Additionally, a dry lubricant coating is added to the contact faces of the joint to assist the lubrication or lack thereof. High speeds can be problematic for joints fitted with plain friction bearings, even when the transmitted torque is low. Needle bearing joints are equipped with roller bearings that reduce friction and assist with minimizing and maintaining play and backlash over long periods of time. They deliver a superior lifetime at continuous operations and higher RPM. They feature either a cross and bearing style as shown here, or a pin and block design with needle bearings. Yokes are made from fatigue-proof steel or stainless steel. The cross design is easiest to assemble and the most economical approach. It also has the smallest contact surface between the moving components, and thus less friction. In some applications, especially at high angles where high side loads are present, it can be better to use a pin and block needle bearing design to redistribute the side loads from the bearing cups to the yoke profile. Belden is one of the only certified manufacturers of the military standard or mil-spec universal joints. These military standard joints are specified in regards to dimension, strengths, and offer features like cadmium or zinc plating for corrosion resistance, along with protective boot covers. In order to be QPL-listed, government-approved manufacturer of these joints, an extensive range of tests has to be performed in authorized labs. The mil-spec universal joint is based on a high-strength leveler-style design. They are made from high-grade alloy steel and components, and can be plated with either cadmium or zinc. These joints are tested and certified per military standards. In the heavy-duty line, boots are packed with lubricant for extended life. Mil-spec joints and their semi-custom variants are commonly used in aerospace and defense applications. Sometimes, a single universal joint is not enough to compensate for all misalignment in a mechanical system, so a combination of joints, usually two, can help. Double universal joints can be manufactured either by butting two single joints together, referred to as a double butted joint, or as a double joint with a double yoke in the center section. Double universal joints can be constructed in all design types: heavy-duty, high-strength, needle-bearing, leveler, and stainless steel. As with most of our joints, double universal joints can be equipped with protective boots as well. Driveshaft assemblies are required for axial misalignment or applications where axial movement occurs during the rotational power transmission. The axial slide can also be used for easy installation on the assembly by compressing the assembly and sliding it into a connecting shaft. Driveshafts offer flexible links as needed. Depending on the nature of the application, driveshafts can be constructed as axially free versus axially retained to allow for the shaft to be fully removed from the sleeve or long yoke at the other end of the assembly. If constructed as axially free, it is recommended that the shaft and sleeve be marked to ensure proper phasing of the assembly when put back together. If the assembly utilizes a spline shaft, one or two teeth can be removed to assist with phasing as well. Spring-loaded assemblies can be constructed, made per specification with preloads for a safe connection. Drive shafts, as well as double universal joints, can be operated with near constant velocity. That means a typical speed fluctuation between driving and driven shaft that is present for single universal joints during a full revolution is compensated. For this to happen, inbound and outbound yokes need to have the same angle, either in a Z or W arrangement. One note of caution: even though driving and driven shafts are now at constant velocity, this is not true for the center. This is still fluctuating, which can cause problems at elevated speeds. This is all depending on the size, torque, and length of the assembly, but our engineers are happy to assist with any specific application questions. Custom drive shafts can meet the requirements of a variety of challenging applications. These examples show how the custom assemblies come together with both custom hub features as well as a custom shaft for axial movement. The top left assembly is a meat slicing application, and this features a split hub with a spring-loaded spline shaft. This is also referred to as a quick change assembly. The drive shaft in the top middle is used in packaging equipment and features male ends that are turned down with a square shaft that is not spring-loaded. There are numerous variations of how drive shafts can be constructed, depending on your application needs. Most of our standard alloy yokes are manufactured from 1144 steel and selectively hardened. Other materials, such as 4142 steel, may be used depending on the universal joint size or series. Most standard alloy blocks and pins are manufactured out of hardened 8620 steel for increased strength, durability, and performance. Our standard stainless steel yokes are manufactured from 303 stainless steel. Standard stainless steel blocks and pins are manufactured from hardened 416 stainless steel to prevent premature galling and wear. All components are precision machined, selectively heat treated where applicable, and manufactured to close tolerances. Special applications and custom solutions may require unique materials to deliver higher strength, improved durability, corrosion resistance, and other qualities. We offer a variety of stainless steel alloys along with aluminum, bronze, and brass alloys, duplex stainless steel, and super alloys such as Inconel, titanium, and more. Besides the choice of materials, joint component corrosion resistance and required operating characteristics can also be achieved or improved by applying special coatings and surface finishes. These finishes can be applied either in specific areas or to the entire joint. Some common coatings and surface finishes include cadmium, nickel, zinc, black oxide, and electropolish, just to name a few. In situations where continuous lubrication is difficult or impossible to supply, or if the universal joint assembly is going to be operated in an atmosphere that's polluted with chips, dirt, acids, or other corrosives or abrasives, it is highly recommended that protective boots be added to the assembly. Boots play an important role in protecting the universal joints. Because the boot inhibit lubrication loss, they can be used to keep a friction-bearing joint fully lubricated. Proper lubrication will considerably prolong the useful life of a universal joint. Boot materials and examples include nitrile and silicone, which are Belden standard, as well as neoprene, Viton, and EPDM, which are available upon request. Even metal covers can be designed, as you can see at right. There are a wide variety of lubricant types suitable for various operating environments. Project requirements or certifications will determine the kinds of lubricants or grease to be used. These are just a few examples of lubricants and their applications. For example, food-grade grease, conforming to FDA regulations, can be used for food processing, marine-grade grease for naval applications, and aerospace-grade grease for a variety of aerospace applications. Universal joints are used in countless mechanical power transmission applications. They offer support highly critical operations. For example, surgical equipment, aerospace applications, defense, or testing. These are some other examples of where our universal joints are used, and of course there are many, many more. Now we'll get into a few case studies from the automation and metal processing industries. This first case study presents a universal joint solution developed for food production automation equipment, in this case, a pick-and-place robot. A customer was having a problem with a standard cross and needle bearing joint during the washdown phase on the automation equipment of this food application. The needle bearing joint would absorb the chemical solution used twice daily to clean and sterilize equipment. Once the alloy bearings absorbed the chemical compounds, gumming would occur, causing the joint to run tight, lock up, and fail. After discussing operating conditions and product specifications with the customer, Belden Universal developed a precision-engineered pin and block joint completely out of stainless steel with composite bushings, which provided a corrosion-resistant, lubricant-free, low-friction plain bearing joint. The low-friction pin and block plain bearing design enables a higher torque capacity for the friction-bearing joint, with the needle bearing's ability to continuously operate at higher speeds with less wear and even less backlash. The composite bearings can handle harsh abrasives found in the cleaning products used by the customer, allowing the joint to operate freely and cycle for a longer duration before any precision was compromised. Belden Universal's solution provided the customer with a completely washdown safe universal joint, eliminating corrosion issues, contamination, burnout, and joint seizure. This case study highlights the importance of customization in order to satisfy all aspects of operating criteria. A customer's high-speed leveling machine operated with a Driveshaft assembly containing a traditional pin and block universal joint. The speed of the application caused the components to overheat and posed a considerable fire hazard. To address the problem of overheating, Belden Universal's engineering team recommended replacing the pin and block component of the Driveshaft assembly with a re-lubricatable forged cross and needle bearing style joint. Cross and bearing configurations don't present as much friction on the surface of the yoke, therefore significantly reducing the issue of heat generation. However, as was the case in this example, the swing diameter of a standard cross and bearing joint is often too large and doesn't fit flush with the other existing components. To resolve this problem, Belden's design team modified the yoke ears of the original Driveshaft to align with the larger outside diameter of the new cross and bearing component. The assembly was manufactured from high-grade alloy steel. The yoke ears were hardened and ground for increased torque capacity. A special telescoping spring loading feature is provided for easy on and off installation. The array of customization resulted in a high-performance, low-maintenance driveshaft optimized for speed, torque, and available space, as was appropriate with the customer's metal processing machinery. Some of our distribution partners may be wondering, where do I find universal joints in my customer's equipment? In the next few slides, we'll go over a collection of examples to give you some ideas on where to look for U-joints in a mechanical system. Universal joints are common in the food and beverage industry applications, such as these three examples from a conveying system, a bottle filling and cleaning line, and a labeling line. A few more specialty applications for you. 3D motion in a flight simulator platform, specialized testing equipment, such as crash test dummies, automation and robotics platforms, such as a Delta Picker robot, and on subsea remote operating vehicle platforms. This list gives you a selective, but not exhaustive, list of common machinery that require universal joints or specialty drive shafts. Our joints are widely used in aerospace, agriculture, automation and robotics, drilling and tapping, food and beverage, industrial machine tools, energy, material handling equipment, military and defense, medical devices, metal processing, packaging and conveying, printing, and marine applications. If you have questions or require more information on your specific application, please do not hesitate to contact Belden Universal's team of sales and application specialists. This wraps up our presentation on Belden Universal's joints and drive shafts. If you have any questions for us, or would like to discuss a current need or design project, please feel free to reach out to us. We are available to take your questions via email, chat on our website, or by calling our offices at these numbers. We appreciate you taking the time to watch our presentation and hope you have a great rest of your day.